last day of the conference. I'm Gareth MacDonald, and it's my pleasure to introduce this morning's topic. We're examining some of the less conventional feedstocks that we could use for our energy production. My own background, I'm a materials handling engineer, and I started dealing with biomass back in 2004, so it's been quite an interesting journey to see the different feedstocks and where they go. So I'm really looking forward to the panel's presentations this morning and hopefully some good questions at the end. Our panel today, as you see, contains some of our leading experts in this industry. Before we get to them, just a couple of housekeeping things. Number one, if you could all switch your cell phones to silent, get distracted. Take a quick moment to have a look around, spot where the emergency exits are. Hopefully we won't need them, but just in case we do, it's worth seeing. Make sure that you've downloaded the BVI app, because that will give you access to all of our presentations here today and all of the presentations that have gone on through the week. Finally, we'll have a little bit of time at the end for questions. There is a microphone at the centre of the room. If you have a question, please step up to that. If you're comfortable doing it, please tell us your name, tell us the company you work for, and the questions addressed to. We'll try to answer it. One last bit of housekeeping, shout out, thank you to Caden, who's looking after our AV this morning. Really appreciate it. Okay, we'll get to it. First presentation is by Terry Moore. Terry is Chief Business Development Officer for WastAway and has more than 20 years of experience in the waste-to-energy industry and significant experience leading technology-based startups. He spent 20 years working at a Fortune 500 diversified natural resource company, and he's been instrumental in several startups that have created a marketable material from waste products. Terry's got a bachelor's degree in chemistry, graduate work at Auburn University, finally earned his MBA at the University of Alabama. Please join me in welcoming Terry.
Thank you, Gary, and I appreciate the opportunity to present our technology and our company, WastAway. It's a long name. We're not allowed to use the E.
Okay, so
let's see. First slide. You did each.
okay.
Okay.
There you go.
There we go.
See, the line shows up pretty damn
I always like to think that innovation and technology development comes from problems that need to be solved for the most part. And the problem that gave birth to WastAway is a problem called landfills. And landfills, as most of you know, are just a hole in the ground that you dump garbage into. That's been going on since civilization began. Science called archaeology that researches old landfills to tell us about those cultures. The problem with the landfills that we have today, as with all landfills throughout history, is that they leach and leak chemicals into the groundwater. They are a haven for vectors such as birds and rodents. They are smelly. Sometimes you catch on fire. There's a lot of traffic, trucks that come and go. And they have methane emissions from the waste that is percolating in the landfill. There's been a lot of work with landfills over the last few decades since RCRA was established. Nevertheless, there's two types of landfills, and that's those that leak and those that will leak. So eventually that always happens. So we had the U.S. Army Corps of Engineers approach us about trying to come up with a solution to the problem that they saw with landfills, because Army bases are basically islands that are surrounded by land, and they would prefer to use their land for things things other than dumping garbage into it. So, and overseas, they're not allowed to dump their garbage, so they have to fly the garbage back to the United States to put in landfills. So they approached us back in the 90s with the Corps of Engineers to try and develop an automated system that would find the benefits that are in waste instead of just burying waste. Because we look at waste, municipal solid waste, as a resource. There's a lot of carbon units there. That's why the methane that escapes from landfills is produced by the bacteria in the landfills. And that methane is 25 times more potent as a greenhouse gas than CO2. So we began to work on developing this process, and by the early 2000s, we built a plant in Warren County, Tennessee, to process the municipal solid waste of Warren County, Tennessee. We have operated that plant since 2003. The technology that we started with has evolved as technology has to. You either innovate and move forward, or you get past. That's the nature of technology companies. We have, over the course of 2 decades, received numerous awards, including R&D Magazine 100, Best Companies, Best Inventions. The Army Corps of Engineers has given us several awards, and we've been vetted by numerous third-party engineering companies as part of due diligence for potential projects that we have been involved with. So, it's safe to say that technology is proven, somewhat mature because we keep maturing all the time, but we're very satisfied with the results that we get. And I'll try to keep up with the slides here.
Click again. Click again.
You can see that.
Click it again.
Yeah. It's that
Like I
green
told
heat.
Green.
We have several numbers that we like to claim. We divert basically 85% of the garbage that comes into our plant is diverted away from the landfill. This is through recycled materials or through energy products that we make. We have more than 25 patents, U.S. and international. We have 20 years of experience running the plant. We've actually run waste from all over the world because everyone says their waste is different. But what we found out is when we run through our process, the end product's always the same. And I can explain that here in a few minutes. Interestingly enough, 100% of the food waste that goes into your garbage can and comes to us is processed and recycled as an energy product. We have finished feed studies for 2 different projects, and we're awaiting permits to begin construction. And our typical plant is 400 tons per day of input. That's U.S. tons per day of input MSW. Back up. Yeah, there we go. It's a pretty simple explanation here, and that is you have inputs, which is the garbage. It can come in as sorted, or it can come in as unsorted. For you people not familiar with this phenomenon, or if you live in places that make you separate your garbage out into different bins, it doesn't matter to us how it comes in, because our sorting line is automated and takes out the recyclables in distinct places so that they can be sold. That would be the ferrous and the non-ferrous metals and certain plastics and the inerts, because what we're looking for is a carbon-rich material that is then introduced into our patented cellulator, as we call it, which is very much explained by autoclave technology, but it's a continuous flow process where waste, the material comes in, high cellulosic value, 70% of what came in is cellulosic. It goes into a chamber where it moves through the chamber over a period of 25 to 30 minutes. It is intimate with steam at a high pressure and high temperature. In fact, the temperature, pressure, and dwell time in our cellulator exceeds the standards for surgical instruments in a hospital. So that when the material comes out of the cellulator, the moisture in the water that was inside the cells has turned to steam, and when the pressure is released, it explodes the cells. So you wind up with a pathogen-free, sterile material we call cellulite that's uniform size, about a quarter-inch down. It looks like the material in your attic, basically. That material is well suited for other processes. You see a picture of it here. It can be processed further as cellulite can be processed further to what we call SE3 fuel, which is a perfect substitute for coal and other fossil fuels that are burned in cement kilns and power plants and gasification projects. Or it can be used as a feedstock for anaerobic digesters. I think there's a quote up there I would like to give David Palmer credit for, that anybody can grind garbage. We manufacture fuel, and that's really what we do. So we've seen the inherent value that's in waste, and we've captured that now, and we've monetized it in the marketplace. Oops. In the last 3 years, we have added to our process anaerobic digestion. As you know, why we're here is renewable natural gas. And when David joined our company, he suggested that our material was amenable to a feedstock for an anaerobic digester. There's a pretty high percentage of the tresticles that are easily digested. So we began doing biomethane potential tests with the University of Wisconsin in Madison, which is sort of the gold standard for BMP testing. The results were very, very encouraging. So we began shopping for an anaerobic digester company as a partner. And in February of 2023, we also initiated a pilot scale test that ran for almost a year and a half continuously. And the results were very encouraging, such that the anaerobic digester company was ready to go into business with us and supply the digester on the back end. And what we get out of the digester is renewable natural gas, but we also get a digestate. And that digestate is the solid portion of what was fed in. And it has a considerable BTU value as well. We take that digestate and we dry it, and we take whatever materials that we didn't feed into the digester, like textiles, that have carbon value, and we blend those together and we produce the SE3 fuel. And this fuel, whether it went through the digester and came out as digestate and was reformed basically into SE3, or whether we took it straight out of the cellulator and dried it and it was SE3. The BTU value is akin to coal. It's between 9,000 and 9,500 BTUs per pound. We can pelletize that, which a lot of gas-fired companies have asked us to do. And a lot of companies, like power companies, like to feed it in its fluff form. We chose an anaerobic digester company that has had digesters in operation in the U.S., in Europe, and in Canada since the early 90s. Digesters are pretty much hands-free type devices. I'm sure you all are familiar with and how they work. But basically, a digester takes 28 days for the material to move through, and what takes 10 years in a landfill. It runs continuously, 24/7, and it's fed and it discharges continuously. So it's a very proven technology. I always tell people that we have our own anaerobic digester system. It starts with our mouth and it ends somewhere down below. And just like anaerobic digesters, we have the same outputs. And you can fill in the blanks on that. We have two projects that we're currently finished with our feed study, and we're awaiting permits. One is in California, and the other one is in Murfreesboro, Tennessee. Just to point out where WastAway is located, we're halfway between Nashville and Chattanooga, Tennessee. And we operate the plant in McMinnville, or Warren County now, for generating material for test purposes for people who want to test their kilns and their furnaces with this material. We have tested successfully with every major cement company in the world. The results are always positive. We have LOIs at each of these sites with cement companies wanting to purchase this fuel. And we have basically been waiting for the permits to be finalized so that we can begin construction. Hopefully we'll have the Murfreesboro plant coming out of the ground here in the next few months. Just some equivalents quickly. One 400-ton per day plant of WastAway will remove the equivalent of 96,000 automobiles from the highway every year. Another way to look at it is we avoid 860 billion pounds of CO2 from escaping into the atmosphere, which is what it would have done with landfills. And this is equivalent to planting 517,000 acres of forest every year. This is for one 400-ton per day plant, which is a typical size for a medium municipality. And our tagline is today's trash, tomorrow's fuel. Just to reiterate, we see that trash, garbage, waste has value. And if you can keep it out of the landfill, why would you ever want to bury it? And that's what this process does. And it diverts 85% of the incoming material to the landfill. Thank you very much.
Thank you, Terry. That's fascinating. It's two key things, doesn't it? It's it treats the waste, gets rid of the waste, and